Hello everyone. In series with complex analysis, we are discussing today the topic of analytic functions. So before going to the topic, we have to know some of the basics definition. The definition is we have to understand what is analytic function. A single valued function fz which is differentiable at z is equals to z naught is said to be analytic at the point z is equals to z naught. The point at which the function is not differentiable is called a singular point of the function. So this is about the analytic function. This definition I have taken from H.K. Das, Advanced Engineering Mathematics. So you can also see the book for detailed study. Now the necessary condition for fz to be analytic theorem. First theorem is that the necessary condition for a function fz which is given u plus iv. Here u is the real part and iv is the imaginary part of a given function. To be analytic at all the points in a region R are, first is del u by del x is equals to del v by del y, and second is del u by del y is equals to minus of del v by del x. So here if the function fz is given, then you have to find the real and the imaginary part, and then you have to put these two equations. These are all also called the Cauchy-Riemann equation. So you are very much familiar about these two. So we have to put the definitions here, and then we discuss with detailed example. You can easily understand that how they are getting to be used in the question. So then we have to discuss one more definition. Now the second one is the sufficient condition for fz to be analytic. So this is theorem 2. The sufficient condition for a function fz is equals to u plus iv to be analytic at all the points in a region R are del u by del x is equals to del v by del y, del u by del y is equals to minus of del v by del x, and second one is that del u by del x, del u by del y, del v by del x and del v by del y are the continuous function of x and y in a region R. So this is about the sufficient condition, or this is the second theorem we can say. So these two on combining gives the Cauchy-Riemann equation. Now the next one is the harmonic function. So you have to just learn the definition or revise the definition, then in next slide I have to explain you that how they are getting to be used in the question. So what is here? Harmonic function. Any function which satisfies the Laplace equation is known as harmonic function. So for this the theorem is given: if fz is equals to u plus iv is analytic function, then u and v are both harmonic functions. So here the proof is given that fz is equals to u plus iv is an analytic function. Then we have del u by del x is equals to del v by del y, and del u by del y is equals to minus of del v by del x. So combining these equation 1 and 2 we get the Cauchy-Riemann equation, and differentiating equation 1 with respect to x we get del square u by del x square is equals to del square v by del y of del x. This is now equation 3, and again differentiating equation 2 with respect to y we get del square u by del y square is equals to minus of del square v by del x and del y. So on adding equation 3 and 4 we get del square u by del x square plus del square u by del y square in the left side, which is equals to del square v by del x del y minus of del square v by del y and del x. So on combining del square u by del x square plus del square u by del y square is equals to 0. Similarly, del square v by del x square plus del square v by del square y is equals to 0. These are called the Laplace equation. Since you know del square v by del x del y is equals to del square v by del y and del x. So in partial differentiation we can take the order, means we can firstly differentiate with respect to x and y, and also do first with respect to y and then x. So these are called the Laplace equation. Therefore both u and v are the harmonic function. Such function u and v are called the conjugate harmonic function, as u plus iv is also analytic function. So this is about the harmonic function. So now we are discussing how they are getting to used in the question. Now the analytic function. So in briefly we have to again discuss how they are used in question. Fz is equals to u plus iv is an analytic function at z0 if it is differentiable on some neighborhood of z0. First one is Cauchy-Riemann equation satisfied at neighborhood and function continuous at neighborhood. So in the right side you have seen a figure that neighborhood of a point z0. Here mod of z minus z0 is less than r, means a circle of radius r, z0 is a point. So neighborhood of z0 is the red line shown here in the figure. So here this is about the neighborhood of z0. Now the second one is the harmonic conjugate. So what is harmonic conjugate? V is harmonic conjugate of u if Cauchy-Riemann equation satisfied, ux plus vy and vx is equals to minus of uy. This is called the conjugacy, or here ux is representing del u by del x and vy representing del v by del y. So these are the equations. The second one is u and v satisfied Laplace equation. So in harmonic conjugative you have to learn the what is Laplace equation. So del square u is equals to 0, which is equals to del square v. On combining this we get del square is equals to del square u by del x square plus del square by del y square. Here u xx representing double derivative with respect to x of u, and u y representing double derivative of y, which is equals to 0. Similarly for the function v, here u is the real part and v is representing the imaginary part of the complex function. So these two are the important Laplace equation. Now second star note point is fz is equals to u plus iv is analytic if v is harmonic conjugate of u. And here third one is analyticity represents differentiability at every point. So now we are taking a example. Here example fz is equals to x plus iy square. Fz is differentiable at z is equals to x plus iota x. X belongs to the real numbers. Here u is equals to x square means real part is x square and imaginary part v is equals to y square. So we have to put in equation uxx means double derivative of real plus double derivative of real with respect to y and with respect to x. On combining this we get 2 plus 0, which is not equals to 0. Similarly for vxx plus vyy is equals to 0 plus 2, which is not equals to 0. So here u and v are not harmonic. Fz is not where analytic on complex function. So this is about this example. Now this is a question of NET June 2017. Fz is equals to u xy plus iv xy is analytic with u is equals to e to the power ax cos by. Here ab belongs to r. A is not equals to 0 if these are the options given. First one is b is equals to 0, second b is equals to plus minus of a, and third one is b is equals to plus minus 2 pi a. Fourth one is b is equals to a plus 2 pi. So here the solution is like this. Here u is the real part of the function is given. So we have to find the value of a or b in the from the options. So here solution is uxx means real part double derivative with respect to x plus real part double derivative with respect to y is equals to 0. So u is equals to e to the power ax cos by. So on first time differentiating with respect to x we get a e to the power ax of cos by. Similarly uxx we get a square e to the power ax of cos by. And similarly uy is equals to minus of b e to the power of ax and by. Similarly uyy is equals to minus of b square e to the power ax of cos by. So from here e to the power ax of cos by, which is a function, on taking common, combining the two equation we get a square minus b square is equals to 0. So here this is the given function which is equals to 0. Now the constant part a square minus b square is equals to 0. So on equating we get a is equals to plus minus b or b is equals to plus minus a. So in option b is equals to plus minus a is given, but a is equals to plus minus b is not given. So second one is the correct answer. Now here one is the important note point. A non-constant real valued function can never be analytic as fz is equals to u plus iota 0. Cauchy-Riemann equation is ux is equals to 0 or 0 is equals to minus of uy. So here u is a constant. So a non-constant real valued function can never be analytic. This is the important point. Now, this is a question of NET December 2013. The question is, which of the following cannot be the real part of analytic function? So, from the node point, non-constant real part cannot be the analytic. So, here from the option we have taken u is equals to x square y. So, just putting the condition uxx plus uyy is, so on simplifying we get double derivative of u, we get 2y is not equals to 0, and uyy is equals to 0. So here 2y is not equals to 0, means this function, this condition is not satisfying. So this cannot be the real part of the analytic function. So this is not analytic. For other three option, if you do the same condition, then they are equals to 0. So they may be the real part of the analytic function. But first option is not the analytic part of this function. So this is about this example. Now this is a question of NET June 2012. The question is, u is equals to x plus 1 by 2 x square minus y square be the real part of analytic function fz, then imaginary fz is equals to what? This is our question. So real part is given, we have to find the imaginary part. So from the option we have taken y plus xy as a function. So how we have to select this one? So just see the solution. Ux is equals to Vy. This is first Cauchy-Riemann equation. So Vy we have to find, u is given. So when we differentiate u with respect to x, what we get? 1 plus 2x by 2. So 2 and 2 is cancelled. We get Vy is equals to 1 plus x. On integrating with respect to y, we get y plus xy. So here we are integrating with respect to y. So if some function phi x is a function of x, so on integrating or on differentiating it is equals to 0. So there is no change in the function. So we can put here a phi x is a new function. Now the second Cauchy-Riemann equation is Vx is equals to minus of uy. So we have to find Vx, means differentiating u with respect to y. So what we get? We get minus of 2y by 2. So 2 and 2 is cancelled out. We get Vy is equals to uy is equals to minus of y. So on equating with second equation, we get Vx is equals to y. So here we also put a function phi dash x. So there is no change in the function, y plus phi dash x is equals to y. So here phi dash x is equals to 0. So on integrating, phi x is equals to a constant. So what is the imaginary part of the given function? V is equals to y plus xy plus c. So this we have to find out, that in this analytic function the imaginary part is v is equals to y plus xy plus c. So this is about this example. Now this is the last example of this lecture, and this is a question of NET June 2018, and this is from set B, question number 22. So what is this? What is the value of alpha for which fxy is equals to 2x plus 3x square minus y square plus 2 iota 3xy plus alpha y is an analytic function of complex variables z is equals to x plus iota y? So what is the value of alpha? We have to find the value of alpha for the given function, and this function is analytic function. So we are getting to use a function analytic condition of the function and just finding the value of alpha. So solution is like this. Fz is equals to u plus iv is an analytic function. If Cauchy-Riemann equation is satisfied, means del u by del x is equals to del v by del y, and del v by del x is equals to minus of del u by del y. This is the conjugacy condition. So for the given question, fxy is equals to 2x plus 3x square minus y square plus 2 iota 3xy plus alpha y. So here u is equals to 2x plus 3x square minus y square. This one is the real part, and v is equals to 2 3xy plus alpha y. This is the imaginary part. So del u by del x, we get 2 plus 6x, and del v by del y, we get 6x plus 2 alpha or alpha 2. So from first Cauchy-Riemann equation, del u by del x is equals to del v by del y. On equating, we get 2 plus 6x is equals to 6x plus alpha 2. Here alpha is equals to 2 by 2 is equals to 1. So alpha is equals to 1 is the correct answer. Here the four options are given. A is equals to 1, B is equals to 0, C is equals to 3, and D is equals to 2. So this is about this question, and the correct answer, the value of alpha is equals to 1. So this is about this question. Thank you very much. Keep watching.